In this session, we're going to talk about gases, an introduction to gas. Now, we know on Earth we have a lot of gases, okay? So, we want to know what are the percentages of the gases that are in the atmosphere of Earth. So, let's start with nitrogen. Now, the percentage of nitrogen, it's going to be what? It's going to be 78% of Earth gas. Okay, as you can see, 78% of nitrogen gas. Now, what about oxygen? Now, oxygen percentage is going to be 20.95% of Earth gas. What about another gas? Argon. Now, argon, it makes up 0.93% of what? 0.93% of what? Of the of argon in atmosphere, the gas. What about carbon dioxide, CO2? What is the percentage of CO2 in Earth, in the atmosphere? You're right, it's going to be 0.038% of CO2 in the atmosphere of Earth. Now, the last one is water vapor. Yes, we have 1% of water vapor in our atmosphere. So I think that's a new one for everyone, that we have the water vapor in our atmosphere. Okay, so those are the percentages list for each gas and Earth. Okay, so imagine here we have a balloon that we filled it with air. We know that gas particles, they're not like solid or liquid gas particles. They're moving away from each other, the particles. That's why we have that shape of the balloon, because they're hitting the barrier of the balloon and it's having that oval shape. Now imagine that we take that balloon and put it at the desert, okay, at 12 o'clock, okay, at the desert, and it's going to be super hot. You can see that the balloon, after a while, it will pop. Why? It's because we're increasing here the kinetic energy of the gas particles, so they're moving much faster, okay? They're hitting the barrier of the balloon much faster. So because of that, it's going to pop. So you can think about that if we increase the temperature, the gas particles will move faster and faster because of the kinetic energy. Now imagine you take the same balloon, or we take another one because the other one it popped, and put it at the desert at the midnight. And we all know at the midnight of the desert it's going to be super cold. Okay, I will put it there. You can see that the balloon will start to shrink, okay? It won't be that much big, it's going to be shrinking. Why is that? Now we know that gas particles have kinetic energy, okay, but when we lower the temperatures, kinetic energy going to get lower, okay, so they're going to move slowly, okay, so the balloon gets smaller. Now if you didn't understand it, I have a small example that you can think about it. Imagine you have a kid, which is that normal balloon, and you give it candy, and you give him, sorry, candy. You'll see that he'll be hyped. He's going to start running, he's going to make a lot of problems. Now we add to him energy, so it's going to start moving. He's going to be the gas particle in the balloon. He's going to move and do a lot of stuff and break stuff and go and run and scream. Okay, so it's the same thing for the balloon that's under the sun. It has a lot of kinetic energy. It's going to hit the barrier. It's going to move a lot. Then the balloon will pop. Of course, the kid won't explode. Okay, but this is just an example. Now let's take the same kid after we fed him candy, a lot of candy that he loved. That's going to be the example of the balloon at the midnight at the desert. After the kid using all his energy, okay, at running and breaking and screaming, he's going to be tired, okay, so he's going to lose all the energy. He cannot move, he'll be like walking like a dizzy guy, okay, or a drunk guy will be like walking like this. So he's just moving slowly, okay. So because of that, he's going to be like the gas particles inside the balloon that's under, or that's inside the desert at the midnight. It's going to have low kinetic energy, moving slowly as if they're tired. Okay, so that's all about gases, okay, and how. So this is all about the lesson for today, and how it's useful. Okay. So this is only an introduction to gas, okay, but still we're going to have another video which is going to talk more about gases. I'm going to talk about ideal gas law. Now, of course, we need that equation in ideal gas law, which is PV equals nRT. Okay, so that's all about the lesson for today, and I hope it's useful.